All right, so we're going to do one section today, 11.6, areas of multi-sided polygons. Before we find areas of triangles, quadrilaterals, and circles, today you will find areas of other polygons. Areas of regular polygons. What does it mean to construct a circumscribed circle? Does anybody remember? Circumscribed circle? All right. Okay, so circumscribed circle means that you have a shape like a this is a hexagon. If you draw a circle around it so that it goes through each vertex of the regular hexagon, that's a circumscribed circle. It's circumscribing that hexagon. All right. So radius of a polygon. The radius of a polygon is the radius of its circumscribed circle. Right? So that is it's not this distance. It's from the center to a vertex. That's the radius of a polygon. All right. So you'll need to use that to do some calculations and stuff. So make sure you understand radius. It's not the distance from the center to the side. It's the distance from the center to the vertex. Radius of a polygon. Apothem of a polygon. The apothem, I pronounce it apothem. The apothem of a polygon is the distance from the center to the side, right? That's the apothem. The central angle of a regular polygon is, it's kind of hard to see, but the central angle is if you draw two radii, right? Two consecutive radii, then it forms this triangle here. The angle here, that is your central angle of a regular polygon. Let me highlight that so you can see. Here's the apothem. Here's the central angle. Remember, the radius is from the center to a vertex. That's the radius. All right, any questions? All right, in the diagram, WXYZ is a square inscribed in circle P. Identify the center, a radius, an apothem, and a central angle of the polygon. Okay, so using letters, what's the center? Kayla? Yes. P is the center. Give me a radius. Jacob. PX. PX is a radius. We could also say, what else is a radius, Devin? PY. PX and PY. Radii. All right. Give me an apothem, Eric.
Is it XPY?
No.
QP?
QP, yes. QP is the apothem. It's a single line. Give me the central angle, Kaylee. Go ahead, Gates. Central angle.
XPY?
Yes. Angle XPY is the central Angle. Oh, you need notes, don't you?
Yeah.
Let me get you some notes. Yeah, you should have spoke up. You can watch the PowerPoints, the videos of the other lessons are online. You can watch those and fill in your notes from that, Devin. The rest of them. All right. Are you able to get your iPad to work to watch the videos? You can? Okay. All right. So there's the answers there. Okay, so now, they want us to find angle measures in a regular polygon. In the diagram, ABCDE is a regular pentagon inscribed by circle F. Find each angle measure. So they want to know the angle measure of AFB, the central angle. How could we find the angle measure of AFB? We know it's a regular pentagon. That's the central angle. How many triangles of this size do I have in the pentagon? 6? 5. One here, one here, one here, one here. So we have 5. So we have 5 angles that are the same right here. How could I figure out what that angle is?
360 divided by 5.
Right, we do 360 divided by 5. So A angle, the measure of angle AFB is equal to 360 divided by 5, which is going to be 72 degrees. Right, so AFB is 72 degrees. What about AFG? What would AFG be? Somebody say it? Yeah, it's 36 because this apothem divides the triangle in half. So that would be 72 divided by 2, or 36 degrees. Okay, the measure of angle GAF. Okay, how could I find GAF? What would GAF be? Yes.
You would take the measurements of the other two angles in the triangle and subtract 180.
Right. Okay, so we know that this angle is 72, right? So we subtract 72 from 180, and both of these, this isosceles triangle, both of these radii are the same, right? So we subtract 72 from 360 divided by 2. So we've got GAF is 360, not 360, 180, because the triangle is 180. GAF is 180 minus 72, we put that in parentheses, and we divide it by 2. So that's going to be 108 divided by 2, which is what? What's 108 divided by 2? 54. 54 degrees. Okay, any questions on that? No questions, okay? Area of a regular polygon. The area of a regular n-gon with side S is half the product of the apothem and the perimeter. All right. So the area of a regular polygon, no matter how many sides, right, is 1/2 apothem times P, or more commonly you'll use this. 1/2 area equals 1/2 ASN. I know it by, I'll be using ASN, so that's the one, it's the same thing as ANS, but this is how I am used to it, so that's what I'll be saying. So rather than learning this, learn it this way. Area equals 1/2 ASN. Now, SN is the side, S is the side length, okay? S is the length of the side, N is the number of sides. So these two are the same thing because S times N is P, right? P equals S times N. So that's why you can use 1/2 AP or 1/2 ASN. If they give you the perimeter, use 1/2 AP. More commonly, they give you a side length, or you find a side length, and you know the number of sides, and you'll use the 1/2 ASN. Let's look at some examples. Find the perimeter and area of the regular polygon. All right. So what do we need to do to find? Let's find the perimeter first. What do I need to do to find the perimeter? How can we do that? Yes.
Find the side length using the Pythagorean theorem.
Right, we got to do Pythagorean theorem. So we would have 8 squared equals 6.5 squared plus that x, we'll call that x squared. So that's going to be, I'm going to need some help with the calculations here. 64 equals, what's 6.5 squared? Abby, what is it? 42.25. 42.25 plus x squared. So then we subtract 42.25 from 64. So we get 21.75. Right?
Yeah.
Okay. Equals x squared. So what's the square root of 21.75? X equals what?
4.66.
4.66. So it would be rounded to 4.67, or does it go even?
It rounds to 4.66.
0.66?
Yes.
Okay. 4.66. So x is 4.66. So then what is the length of the side going to be? What do I have to do to that? Yeah, we multiply times 2. So that's going to be what? 9 point what? What? 9.32. So the side length is 9.32. So if the side length is 9.3, the perimeter equals 5. It's a pentagon, so it's 5 times S. So that would be 5 times 9.32, right? And that's going to give me what? 5, Jacob?
46.6.
Say again?
46.6.
46.6, right? Is that what, did you round that off to the 10th?
That's what it counted as.
Came out as? Okay. All right. So now, since I know the perimeter, I could have used 1/2 ASN because I know the side, number of sides, and the apothem, but since we found the perimeter, let's just use 1/2 A equals 1/2, area equals 1/2 AP. So we plug in, that's going to be 1/2. The apothem is 6.5, and the perimeter is 46.6. We multiply that out, what do we get? You got it, Jacob?
151.45.
Okay, so the area equals 151.45, and that's units squared. All right, any questions there? All right, get the process. No questions. Everybody has it. Okay. Find the area and the perimeter of the nonagon. All right. So here we have the side length we have a side length and we have the radius. Before I can find the area of this shape, what do I need to know? What's missing? I can't calculate the area of this till I know this missing part. What part is missing? Number of sides is 9. Nonagon is 9. The apothem. We have to find the apothem, right? So we know that this length is. Let me go back. So we've got this length is 16. Okay. And then this length here, we could do half of. We would do half of 8.48. 4.24, right? So I have, well, that's kind of murky. Let me redraw that. Let's do it over here. So we know that the radius is 16, and we have to find the apothem, which is here, right? And then this distance of the triangle. Were you tardy?
What?
Are you tardy? All right, so that distance of the triangle is 4.24, 8.48 divided in half. So how can we find the apothem? What am I going to use? Carly?
The 16.
What formula am I going to use?
I don't know.
This is a right triangle. Pythagorean theorem, right? So it's going to be 16 squared plus, let's call it the A, the apothem, A squared. 16 equals A squared plus 4.24 squared. Right? So that's going to be what, 16 squared, what's that, 256? I need some help with calculators. What's that? What is it? 256 equals A squared plus what's 4.24 squared? Gunnar? 17.98. So then we subtract A squared is going to equal to 38.02. Square root of that, A equals what? Square root of 38.02. Go for it, Gunnar.
I need 250.
What's that?
I think it's supposed to be the square root of 238.
Yeah, 238. Okay, yeah, you're right. 238.02. Square root of 238.02.
I got 15.43.
15.43. Right, so the apothem is 15.43. All right, so this is 15.43. All right, now I can figure out the area of the shape. Area equals 1/2 ASN. So we plug in, we've got 1/2. The apothem is 15.43. The side length was, don't use the 4.24. Remember, the side length is not just the half of it, it's this length, so it's 8.48. times the number of sides is 9. All right, let's calculate that. Go ahead and calculate what we get. Yeah,
588.
588.8. Sounds right. 588.8. And that would be, there's no units, so we'd say units squared. Right? 588.8. Now, the perimeter, we could do it, the perimeter is the number of sides times the side length, so that's S times N. So that's going to be 8.48 times 9, right? 8.48 times 9. So what would that be? Calculate the perimeter. What'd you get?
76.32.
76.32. And that would just be units. It's not squared, it's just a lineal distance. 76.32. All right, any questions on that problem? No questions, okay? Let's see how we did. Oh, they didn't give the answers, huh? Okay. So then we have the radius and this should say the apothem. The word is left out there. That should say the apothem and the radius of the regular polygon are drawn below. Find the area. All right? What's missing to find the area? What do we need to find now? We need to find the side length. How are we going to do that, Brandon? Pythagorean theorem. All right, so we have 2.37 squared equals 2.2 squared plus x squared. So when we multiply all that out, and so what's 2.37 squared?
5.62.
What's that?
5.62.
5.62 equals, what's 2.2 squared?
4.84.
4.84 plus x squared. So then we subtract, what's 5.62 minus 4.84?
0.78.
What?
0.78.
Points x squared equals 0.78. What's the square root of that? X equals, what would x equal?
0.88.
0.88. All right. So x is 0.88.
Now you times that by 2.
Right. We got to multiply that times 2. So 2x equals what? 1.76?
1.76.
Yeah, 1.76. So the side length is 1.76. Now I have everything I need to do my formula. Area equals 1/2 ASN, and that's going to equal to 1/2. The apothem is 2.2. The side length is 1.76, and the number of sides is 1, 2, 3, 4, 5, 6, 7 sides times 7. What do you get for your answer? When we multiply that out. What do you get, Jacob?
13.55.
13.55. We'll go with that. 13.55 units squared. Now remember, these problems don't have meters or feet or whatever, but remember, you're going to get a half point on these questions on the quiz if you put feet squared or meters squared. If you label it with units, that's a half point. Like, so this question would be worth 2.5 points. That 0.5 is for the units. Okay, so make sure that's like a free point. So make sure you get it. All right. Find the perimeter of a regular n-gon. Okay. A regular nonagon is inscribed in a circle with a radius of 4. Find the perimeter area of the nonagon. All right. So here we're going to, if they just give you one length. Before, all these problem examples before, we had 2 lengths, so we could do Pythagorean theorem. Now I've got to use trig. Okay. So if it's a nonagon, how can we find a measure of its central angle? What will we do? We talked about this once before. What do I do? The central angle, we've got 9 central angles the same size. How would I figure out the measure of the central angle? Yeah.
360 divided by 9.
Right. So the measure of the central angle is 360 divided by 9, which is going to be 40 degrees. The measure of the central angle is 40 degrees. All right, now we have to find the legs of the triangle. So this angle is 40, but I want to use half of that, right? To make that right triangle with the apothem. So I'm going to have a triangle. If we draw it like that, the hypotenuse is 4. This angle would be not 40, but what? 20. So I'm going to use 20 and 4, and we need to find both the side length and we need to find this length is the apothem, and then this is half the side. So we have to find both of those. So if we find, let's find, so we'll call this let's call this length x, and we'll call this length y. So to find x, using SOHCAHTOA, we can say that is involving, we have the opposite and the hypotenuse. Which one are we going to use? Which trig function to find x? If we have x, we've got our opposite and hypotenuse. Which one is that? Sine. We're going to use the sine to find x. So we'd say sine 20 degrees is equal to opposite x over 4, right? So x equals 4 sine of 20, which is, what's that give me? 4 sine of 20 gives me what? What's that? 1.87? 37? 1.37. All right. So x is 1.37, but what do we need to do that to help me to solve the problem? What do I need to do to 1.37? Yeah, multiply by 2. So 2x would equal what, Kaylee? 2.74? 2.74. So we need to remember that this s equals 2.74. All right. Everybody have all that? Okay, now let me create some space, and we'll do A, the apothem. Okay, so that's going to be y. So y, we've got 20. Y is the adjacent. 4 is the hypotenuse. Which trig function am I going to use now?
Cosine.
Cosine. All right, so we're going to say cosine of 20 degrees equals y over 4. So y equals 4 cosine of 20. So what does y equal? Y equals what?
3.76.
3.76. So the apothem equals 3.76. Now I have all the information I need to calculate the area. Okay? the area equals 1/2 ASN. So that's going to be 1/2 3.76 times S is 2.74, and then N is 9. So what do we get for the area? 33.78. Area equals 33.78. So that, this problem, that uses a lot. I mean, that's a lot of work, right, to find area. But you have to, on these type of problems, you have to use Pythagorean theorem or trig or whatever. So it's multiple steps to find the answer. Now the perimeter, let's do the perimeter. The perimeter is going to equal to the side length, 2.74 times 9. What do we get for the perimeter? 2.74 times 9. 24.66. All right. So this would be, the top one would be units squared. This one would be just units. All right. Any questions? Thumbs up, thumbs down. Who thinks they can work this a problem like this? All right. Rely on your notes. Okay. Look back at your notes as an example. So here they went. Okay. They did that. All right. Find the area of the shaded region. Looks like we need some more information. Find the area of the shaded region. We don't have any lengths here.
There's lengths on the notes.
What's that?
There's lengths on the notes.
Oh, there. Okay, let's see what your notes say. We've got, this is 3, and this is 5. All right. We've got 3 and 5. Okay, so, and this is a right triangle. What do I have to do first on this? What would be my first step? What? Okay, well, yeah, we're going to say, let's say the shaded region is the blue. So you have to find the area of the circle. But before we do that, what should we do? We have to find the area of the pentagon, right? So what do I need to do to find the area of the pentagon? What's the first thing I need to do there? We don't know S. We don't know the side length. How am I going to find the side length? Yeah, we got to do Pythagorean theorem. So that's a 3, 4, 5 triangle, right? This is 3. The hypotenuse is 5. We know that that length would be 4. So the side length is 8. Now I have the information I need to do this total area, do the blue area. Okay, so the area of the blue is going to equal to the, like she said, the circle, pi r squared minus 1/2 ASN. I would prefer, this is how you do it. You combine all this into one formula rather than, doing the circle here and the polygon here and then subtracting. Just write it all together. Then you just plug in. Okay, so we have that equals to pi. The radius is 3 squared minus 1/2. The hypotenuse, nope, I did that wrong. The radius is not 3. What's the radius? 5. Radius is 5. So it's going to be pi 5 squared minus 1/2. And then the hypotenuse is 3. The side length is what? 8. Yeah, the side length is 8. And the number of sides is 5. All right, so that's going to be 25 pi minus, we can take a half, well, let's take half of the 8. So that'd be 4 times 3. 4 times 3 is 12 times 5 would be 60. So what's 25 pi minus 60? What's that? 18.5. 18.5, and that would be units squared. All right, any questions? No questions. All right, I think that's it. Well, more examples. All right, let me see how many more examples I've got. All right, who wants to do more examples, or we can do, I can give you some more of these examples, or if you feel like you've got it, we can go on and do some more general practice problems over the whole chapter. Who wants to do more examples on this? Or feels like they have it? Okay, we'll stop here then.